parallel lines. Before that, we have to recall what it means by parallel lines. Parallel line means the lines which do not intersect with each other. Okay, when we consider about this line, and another line would be like this. Okay, like this. So that means the distance between these two lines, if I measure the distance between these two lines as 3 centimeters, at at every point, the distance between these two lines will not coincide with each other. Okay. Distance between these two lines is always same. So if the distance are same, if it is maintaining the same distance, that will not intersect with each other. No, that will not intersect with each other. These kind of lines are called as parallel lines. Parallel lines means will not intersect with each other. These are the conditions to obtain a pair of parallel lines. Will not intersect with each other. Next condition, the gap. Okay, the gap or perpendicular distance. In your book, they've used the gap between two lines is always same. The gap between two lines are always same. Are always same. These are the conditions to draw a parallel line. Distance between both of these lines, that is always same. Here 3 centimeters, so here also 3 centimeters, here also 3 centimeters. These are always straight line features, okay, not like the curvy features. These are always a straight line features in parallel lines. Not only like this, there might be some slanted lines as well, like this. But somehow, what are the conditions? These two lines will not intersect with each other, and the distance between both of these lines, it would be always same. You can think about a railway straight railway tracks, because these track and this track both will not intersect with each other. No, I am talking about the same track. These two will not intersect with each other. That is the real life example of parallel lines. Only think about the straight line railway tracks. This is an example. Okay, look at this. This is also a pair of parallel lines. What are the conditions? These two will not intersect with each other. The gap between these two lines, if I measure 1 centimeter here, at all places, the measurement should be 1 centimeter. If I measure 3 centimeters between them, no, not 3, 2 centimeters over here. Here also it would be 2 centimeters. When you measure at anywhere along the parallel line, the gap that will not increase or decrease. That will maintain in the same manner. Angles between parallel lines, in that first thing we are going to discuss is corresponding angles. Okay, corresponding angles means easy. If there are, I have a pair of parallel lines. Parallel lines means we know to denote parallel lines we are using arrows. If there are two arrows denoted in a straight lines, in two straight lines, if there are arrows indicated, you should determine these two as parallel lines. Not, they will not write this is a parallel line, this is a parallel line. Not like that. There are arrows given, you should consider those two as parallel lines. And in between parallel lines, there is a line, okay, there is a line that will intersect both of the that will intersect both of the parallel lines. This is not a parallel line, okay. There's a pair of parallel line, another line. Another line that will intersect both parallel lines. This is called as transversal. This is called as transversal. Transversal is playing a key role while creating angles. Transversal. There is a pair of parallel line. If there is a transversal, intersect them. The line which is intersecting parallel lines is called as transversal. When there is a transversal intersects, we will have corresponding angles. To identify corresponding angles, we can use capital F letter. Capital F letter. You have capital F letter like this. The angle over here and angle over here. These two are called as corresponding angles. This one and this one. These two are corresponding angles. Look at this. Here we have a capital F shape. No, not exact capital F shape, kind of F shape. That's the identification feature. Here we have a capital F shape. In this F shape, we have both curvature angles. This angle and this angle. These both are corresponding angles. These two are corresponding angles. Not only them, there are many corresponding angles. Think about the up down. Okay, the right down F shape. This is also a F shape. Think about it. These two angles are also corresponding angles. Look at here. Here you can see the right down F shape. So this angle and this angle. These two are corresponding angles as well. These both are corresponding angles as well. Not only them, there are some more as well. This side, the opposite side capital F letter. This angle and this angle. These both are corresponding angles as well. Here you have a opposite side F shape. Here also we have this angle and this angle. These both are called as corresponding angles. Corresponding angles. The last pair of corresponding angle would be like this. The inverted F. I am using different colors to indicate each pair. Here you can see the inverted F shape. Here also we have corresponding angles. Corresponding angles. There is a pair of parallel line and at the transversal intersecting them. When there is a transversal intersecting parallel lines, that will contribute to create many such angles. One of them is called as corresponding angles. We can use capital F letter to identify corresponding angles. The major feature of corresponding angles are always same. Are same. Are equal. That's the proper word. Are equal. Corresponding angles are equal. If I give you this angle as 50 degrees, if I give you this angle as 50 degrees, this one also would be exactly 50 degrees because these two are corresponding angles. No? Corresponding angles are equal in magnitude. Likewise, think about it. This is a straight line. No? We know the angle over a straight line, it would be equals to 180. Likewise, one angle is 50. This angle is 50. So the remaining angle would be this angle over this straight line. Sum of these two angles equals to 180. One angle is occupied by 50. So remaining angle is 130. It would be 130. Similarly, this red color angle's corresponding angle is this red color one. So this one also would be exactly 130 degrees. This one also would be exactly 130 degrees. Similarly, we know one more theorem, vertically opposite angles. You should implement all the theorems which we studied earlier into this corresponding and alternate and allied angles. Look at this. This one and this one both are vertically opposite angles. We know that vertically opposite angles are same in magnitude. So, the line, this line and this line, two lines intersect, so that will create a pair of two pairs of vertically opposite angles 50, and this one also would be exactly 50. This one also would be exactly 50. Why was that? Because those are vertically opposite angles. If this one is 130, its vertically opposite angle would be this. This one also exactly 130 degrees. This also 130. Now let's come to corresponding angles. This light blue color angle and its corresponding angle, it is 130. And it would be 50 as well. Don't confuse with them. We will do many examples hereafter. So the idea would be when there is a transversal cross-cutting a pair of parallel lines, that will contribute to create many such angles. One of them is called as corresponding angle. We can use capital F left to identify corresponding angles. Here I gave you different colors to indicate each pair of corresponding angles.